Hi students, welcome to WAPSI. So we can go to the next section. First question. 10 identical cells, each EMF 2 volt and internal resistance. That means each cell has the potential of 2 volt and the resistance of 1 ohm. Yes. So the potential is 2 volt and the resistance R is equal to 1 ohm. The internal resistance, actually the resistance is internal resistance. So the capital R is to be changed to small r because it is internal resistance. Are connected in series with the two cells wrongly connected. That means in series. So this is the first one, the second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one, and out of these 10 cells 8 are correct and 2 are wrongly connected. That means just opposite to the actually connected series. So the positive negative connected to positive negative. So the effective potential, what will be the effective potential? Actually each battery has a 2 volt potential and this can be 2, 2, 2, 2, 2, 2, 2 and 2, and the potential given by this battery is minus 2 because it is connected in reverse. So and it is minus 2. So the total potential is, this can be cancelled by this, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 2 is 12. So actual potential is only 12 volt. Okay. Then internal resistance of 1 ohm. See, the internal resistance will not vary by changing the direction. The resistance has only a scalar quantity, no direction. Okay. So total resistance is R is equal to 10 ohm. Okay. Then read the question. And a resistor of 10 ohm. Next, they are already have a resistance, and next they are giving a 10 ohm resistor is connected to the combination. That means a 10 ohm resistor is connecting series. So 10 ohm and a 10 ohm is in series. So the total 10 ohm plus 10 ohm which gives 20 ohm resistance is actually happening there. A resistance of 20 ohm is there. Okay. And the effective voltage is there and the effective resistance is there. And what is the current through the resistor? We need to calculate the current I. So I is equal to V by R, 12 by 20, which is equal to 0.6, correct? 1 point divided by 2 is 0.6 and it is ampere, 0.6 ampere or 600 milliampere. Option A is the correct answer. Okay. So we can move to the second question. Find the equivalent resistance in the given figure. See, this is an infinite series. It is not ending by any kind of resistors. Okay. Actually, we can draw the extended version as 2 ohm. Here a 2 ohm and connected a parallel 2 ohm. Okay. And it is connected to infinite times of resistance are connected. We need to calculate the effective resistance. How? Okay. See, I will this kind of marking. Okay. See, I am drawing a mask at here. Okay. Please don't consider this resistance. So see, now you see what is the difference from the previous image to this image. Actually no change is happening there. Okay, because they are infinitely connected. Okay. So I am giving the resistance between these as R equivalent. Okay, the total resistance is R equivalent, and after connecting these points I am giving R equivalent. Is there make any difference? No, because in this portion is also this portion is also similar to the previous section. Okay, so R equivalent is in here and R equivalent is also there. So I can rub all these connection and just given as R equivalent. Okay, this connection is R equivalent. So R equivalent and 2 ohm are actually in parallel. So what will be the effective resistance? 1 by R1 is equal to 1 by R equivalent plus 1 by 2. Okay, that is equal to 2 plus R equivalent by 2 R equivalent. That means R1 equal to 2 R equivalent by 2 plus R equivalent. Okay. Okay, R1 is the effective resistance between these 2 points, and 2 ohm, R1, 2 ohm are in series. Okay, so R equivalent is equal to 2 plus R1 plus 2, which is equal to 4 plus R1, which is equal to 4 plus R1 is nothing but 2 equivalent by 2 plus R equivalent. Okay, 2 into R equivalent by 2 plus R equivalent. So R equivalent is equal to 4 plus 2 R equivalent divided by 2 plus R equivalent. Just multiply the denominator and the numerator by R plus R 2 plus R equivalent, then 4 into 2 plus R equivalent divided by 2 plus R equivalent plus 2 R equivalent by 2 plus R equivalent. So actually R equivalent is equal to 4 into 2 plus R equivalent by 2 plus R equivalent plus 2 R equivalent by 2 plus R equivalent. Okay, so cut these all data and we can rewrite in the top. Okay, so from this equation R equivalent is equal to 4 into 2, you can write as 4 into 2 is 8 plus 4 R equivalent plus 2 R equivalent all divided by 2 plus R equivalent, which is equal to 8 plus 6 R equivalent divided by 2 plus R equivalent. So that is equal to R equivalent. So I am substituting X as R equivalent. X is equal to 8 plus 6x by 2 plus x. So multiplying these factors we get 2 plus x into x, 2x plus x square, which is equal to 8 plus 6x. That means x square minus 4x minus 8 is equal to 0. Okay, x minus a into x minus b is equal to, okay, x minus a into x minus b is equal to, that means the product of some number is minus 8 and sum of two number is minus 4. Which are the two numbers? And the number is okay, actually we need to find using minus b plus or minus root b square minus 4ac. Minus b is 4 plus or minus root b square is 16 minus 4ac. Minus 4 into a is 1, c is minus 8 divided by 2. 4 plus or minus root 16 plus 32. That is actually 16 plus 32 is actually 48 divided by 2. 4 plus or minus 48. Root 48 is actually 6.9 something. 4 plus 6 is 10. 10 by 2 is 5. We get actually two values. One is 5, and when we subtract 4 minus 7, 4 minus 7 is minus 3. The value of the resistance can be a negative value. Okay, the value of resistance always a positive value. So we only need to take the positive. So 4 plus root 48 is approximately 7. We can take as 6.89 like that. Okay, then 4 plus 6 point something will give point something, divided by 2 gives 5 point something. Okay, if we are neglecting that 5 point something, we get option B, because 5.5 will not get, because 5.5 into 2 is 11. Actually, to get 11 we want to add 4 plus 7, but root 48 never become 7, because root 48 is approximately 6 point something. Okay, so 60 minus 32, yes, 38, 48, yes. So option B is the correct answer. Now next we can move to the third question. The resistance of a carbon resistor is 4.7 kilo ohm, plus or minus 5%. Okay, the color of the third band is, so we need to know how we can give color of each resistor. So according to the color we are actually reading the resistance of a resistor. Okay, when we see a resistor, we want to look to the colors and what are the band given on them, and according to that band we are taking the value of the resistor. Okay, there is a first band, there is a second band, there is a third band. First band gives a first number, second band gives a second number, and the third band is the multiplier. Okay, 10 raised to something. Okay, according to the color, every color, each color has their own values. What are the values? To study that, we need to study a saying, a conventional saying. Okay, that saying is B.B. Roy, Great Britain, very good wife. Okay, these are the only a simple saying, doesn't meaning any sense. Okay, B.B. Roy, Great Britain, very good wife. Okay, I am writing that saying. That is a conventional saying, it doesn't have any meaning. B.B. Roy, Great Britain, very good wife. Okay, what is B? B is black. Black, brown, red, orange, yellow, green, blue, violet, grey. The first G is green and the second G is grey and the last W is white. Okay, and we have a gold in here as -1 and silver as here -2. Okay, so 4.7 kilo ohm, so that means 4.7 into 10 raised to 3, which is equal to 47 into 10 raised to 2. What is 4? This is 0, this is 1, this is 2, 3, 4. Okay, first band is yellow, and 7, this is 5, 6, 7. 7 is violet, and the third is the power factor, 10 raised to 2. 2 is what? Red. So yellow, violet, red is the color of that our desired resistance. 4.7 kilo ohm has a color of yellow, violet, red. So the third color, they are actually asking the color of the third band is, the color of the third band is red. So option D is the correct answer. Then we can move to the fourth question. Yes, the fourth question is also similar, but the question is in different format. The 4 bands of a color code resistor of the color is gray, red, gold and gold. Okay, what is gray? Gray gives, see the gray, the second, the last one, gray gives 8. So the first digit is 8. Yes, we can cut this option. And the second one is what? Gray, then red. Red is 2. 8, 2. Okay, so we can't cut any options. Then gold. Gold is -1. So 82 into 10 raised to -1. Okay, so 82 into 10 raised to -1 is 8.2 ohm. 8.2 ohm only in the first option. Yes, and the gold has a tolerance of 5%. So option A is the correct answer. So actually you need to study the sayings. B.B. Roy, Great Britain, very good wife. Simple. Okay, and the left side, gold has a -1 of power factor and silver has -2 of power factor. And gold have 5% of tolerance and silver has 10% of tolerance. Okay, in most case the tolerance is given by gold or silver. Okay, like 0.1 accuracies can be obtained in any resistor. So we need to only bother about the tolerance given by the gold and the silver. By gold it is 5% and by silver it is 10%. Okay, then we can move to more question. Okay, a wire of resistance R is connected across a cell of EMF epsilon. Okay, EMF is epsilon and internal resistance small r. The current through the circuit is I in time t. The work done by battery to establish the current I. So actually we need to find the work done. Okay, the work done by the battery to establish the current I. So what is the equation which connect power and work done? Power is equal to work by time t. Okay, so work is equal to power into time t. Okay, and what is power? Power is nothing but the product of potential and current. So work is equal to VI into t. So work is equal to VIT. Okay, work is equal to VIT. So in any option we can't see any potential V. So we need to substitute V by V is equal to IR. So work is equal to I square RT. So the work is I square RT. Option B is the correct answer. Work is equal to I square RT. Okay, so we can move to the next question. Okay, for a given electric current, the drift velocity of conduction of electrons in a copper wire is Vd. Vd is the drift velocity and their mobility is U. In a textbook the mobility is represented by mu. In here the mobility is represented by U. When the current is increased at a constant temperature, that means the current get increased. What is mean by current? What is mean by current? Current is the rate of change of charge in a given interval of time. Okay, that means when flow of charge increases, the current get increased. Okay, so actually they are saying that the current is increased. That means the number of charge is increased in a particular point. Okay, that means the flow of current is increased. In order to increase the flow of rate of flow of electrons or charge, actually the drift velocity get increased. What is mean by drift velocity? The mean velocity between a collision, successive collision. Okay, so actually drift velocity is increasing. So in which option the Vd is increased? Option C. Option C is the one and only option which has Vd is increased and U remains the same. The mobility of the charge is remaining same, but the Vd is increased. So option C is the correct option. Okay, so next question is, okay, a moving coil galvanometer is converted into an ammeter of range 0 to 5 milliampere. Okay, it has a range of 0 to 5 milliampere. Okay, the galvanometer resistance is 90 ohm. Okay, so G is equal to 90 ohm, the resistance of the galvanometer. Okay, shunt resistance has a value of 10 ohm. Okay, S is equal to 10 ohm. If there are 50 divisions, okay, then if 50 is given as divisions, then theta is equal to 50 in the galvanometer and ammeter on either side of zeros. Its current sensitivity is, okay, so actually the current, what is the equation for current sensitivity? Current sensitivity is theta by Ig. That means current flown through the galvanometer is will divide the theta, means the division, then we get the current sensitivity. Before that we need to find what is Ig. So Is there any relation between Ig? Is there any relation which connect shunt resistance and resistance of the galvanometer by Ig? Yes, I will write shunt resistance is given by G divided by, that means the resistance of galvanometer divided by I by Ig minus 1. Okay, so S into I by Ig minus 1 is given to as G. Okay, so I by Ig minus 1 is equal to G by S. So I by Ig is equal to G by S plus 1, and I is equal to Ig into G by S plus 1. Actually we have I or Ig? Actually we have I only. So Ig is equal to I divided by Ig is equal to I divided by G by S plus 1. That is G, it is 90 given in the question. What is S? That is 10 given in the question. So G by S is 90 by 10, which is equal to 9. 9 plus 1 is 10. So Ig is equal to I by 10. What is I in the question? I is 5 milliampere. It has a sensitivity of 5 milliampere. 5 by 10 is 0.5. So I is equal to 0.5 milliampere. Ig is equal to 0.5 milliampere because I is equal to 5 milliampere. Okay. So then we need to know what is the equation which connect Ig and the sensitivity. Sensitivity is represented as S, sensitivity equal to theta by theta divided by Ig, which is equal to theta is 50 division divided by the current, that is 0.5 milliampere, which is equal to 50 divided by 5 into 10 raised to minus 4. 50 by 5 is 10. 10 into 10 raised to 4 is 10 raised to 5. So the answer is 10 raised to 5. And which option is that? Option B, 10 raised to 5 division per ampere. See, I have done a unit transfer in here. The Ig is in milliampere, 0.5 milliampere. Actually 1 milliampere is 10 raised to minus 3 ampere. So 0.5 milliampere is 5 into 10 raised to minus 4. Okay, milliampere. So 1 by 10 raised to minus 4 is 10 raised to 4. When the denominator goes to numerator, the power get inverse. Okay, that minus will come to plus, the plus will come to minus. In here it is minus, the minus come to plus, 10 raised to 4. 10 raised to 4 into 10 is 10 raised to 5. Okay, then we can go to the next question. An ideal transformer has a turns ratio of 10. Okay, when the primary is connected to 220 volt 50 hertz as AC source, the power output is, okay, so they are actually asking the relation between the power in the input and output. Options, we can read the options. Equal to power input, that means power output is equal to the power input. Option B is 0. Option C is 10 times the power input, and option D is 1 by 10th the power input. Actually this question is very concept wise, okay, conceptual question, because in every transformer the input and output power is constant. Okay, by using this phenomena, actually we are connecting the relation between potential and current. Vi, V input into I input is equal to V output into I output. Okay, that means the power is a constant from going from input to output section. Okay, by using this concept we are actually developing each and every transformers. Okay, so we can move to the next question. So which option is correct? Option A, equal to power output, that means power input is equal to power output. Okay, option A is the correct answer. Okay, option A. Then we can move to the last question in this section. Okay, the current in a coil change from 2 ampere to 3 ampere. Okay, the current is changing to 2 ampere to 5 ampere. Okay, in 0.3 seconds. The time is given as, the time duration, time limit is 0.3 seconds. The magnitude of EMF induced in the coil is 1 volt. The value of inductance of the coil. So induced EMF, we want an equation connecting induced EMF epsilon is equal to minus L di by dt, minus L di by dt, and epsilon is given as 1 volt, and we only need to calculate the L, we don't need the direction, so we can neglect the minus. L into di, what is the change in current in here? 3. What is the change in time in here? 0.3. So 3 by 0.3 is what? 10. L into 10. 10 L. So what is L? 1 by 10, which is equal to 0.1. The inductance is 0.1 Henry or 100 millihenry. Okay, both are correct. 0.1 Henry and 100 millihenry are correct. So while checking the options, option D is the correct answer. Okay, bye.